To start the simulation in Molflow, you can either get the geometry from an external tool, such as your CAD editor software. We will see that in a different video, but there is also a built-in editor for simple geometries. And today we're going to do a quick simulation where you've got like a gas source and you connect two pumps to it, which actually pump the gas through some orifices. And then we'll calculate the pressure distributions. Now this is a fairly simple geometry where you basically connect pipes, but it can represent many of the system characteristics of a generic vacuum system. And I will try to go through different geometry building tools that you have in Molflow. Just as an explanation why we choose this example, it comes from a paper published in Argonne National Laboratory by Howell and Verl, and they have been benchmarking ANSYS, which is a finite element analysis tool. So they have the simple system in their paper. There you have the description, and also you've got the calculated pressure volume. So if we actually make this model in Molflow, then it's a good way to test if our code is working correctly. And also some other tools which are doing molecular flow simulations, such as COMSOL, use a simple geometry to benchmark the pressure profile. So if we make this simulation, then we can see and we can compare our pressure directly with ANSYS and COMSOL. So to start the geometry, we will go to File, and basically we just go to the New menu. And normally when you launch Molflow, in the upper right corner, you've got this view option, Rules, enabled, which is showing you the axis. Remember that you can rotate with the right mouse button. So we will follow some conventions that we use for accelerator simulations. So normally the longitudinal direction where your beam is going is the Z, Y is pointing upwards, and X is the direction where which you would consider going sideways. Just a remark here, you might have your Molflow showing the axis differently. So if I turn on the left-handed coordinate system, which is a setting, then it's possible that your x-axis will point to the right, which depends on how you prefer it. I will turn it off. Just don't get confused if it's different for you. So basically now we don't have anything on our screen apart from the origin, which is at the 0, 0, 0 coordinates. And what we'd like to do, following the geometry description here, is to have a 5-meter long pipe where we connect two ion pumps. The first ion pump is 1 meter away from the entrance. The second is 3 meters away from the entrance. Then there is an aperture change from 4 centimeters to 10 centimeters after 4 meters. And finally, we've got a 1 meter long section at the pipe. Now the outgassing is constant. It will be always 3 times 10 to the minus 12 torr times liter per square centimeter. And in Molflow, the default pressure unit is millibars, and this unit corresponds to 4 times 10 to the minus 12 millibar times liter per square centimeter per second. So I'm going back to Molflow, and first what we'd like to do is to create a circle. And there are several ways to do that. What we'll do is we will be drawing a 2-dimensional circle, and then we will make a pipe out of it. This is similar to the logic used by several CAD tools. So I'm going to Facet, and here I've got a Create Shape menu, which is giving me different options. I will just put my axis on the screen. And in this case, we'd like to create a circle. So the center of the circle will be at 0, 0, 0, which is marked by the axis origin. So this is correct for us. And we should look at the right side figure, which is describing a circle, and you can see that the direction is pointing to the x direction, which is correct for us. So we'd like to have the circle in the xy plane. And the normal vector, which is like the generic direction of the center of the circle is pointing towards Z, this is also correct. So these values, we can leave it at default. Now this is a time when we will actually give the diameter of the circle. Since this is a circle, both axis 1 and axis 2 will be 4 centimeters long. This is described as the shape, so basically this is a 10 centimeter diameter tube and this is a 4 centimeter diameter tube. And finally, he's asking us how many steps we'd like to do. So here you can choose how fine your geometry you'd like to be. I will put 36. It means that we make a total rotation of 360 degrees, and every 10 degrees there will be a step. So I'm clicking on Create Facet. I'm zooming out a little bit, and here you can see the facet that he has created. If I turn on the rules and turn on the normal vector, then we can see that it's pointing towards the Z direction. Should it be pointing to another way, you can use the facet and sweep normal command. What it does is it makes our circle face the other direction. Now, why do we care about the normal vector? The reason for this is that we'd like to convert this circle to a pipe. And here on this document, we can see that we'd like one long section of 400 centimeters. Later, we will have the extrusions for the pumping ports. And to do that, we use the extrude command, which is also in the facet menu. So I will go to extrude, and here I've got several options. I could either define that I'd like to extrude towards the Z direction by defining a vector to the 0, 0, 1 direction, or since the normal vector is pointing already towards the Z, I can ask him to extrude towards the normal vector and make it 400 centimeters long. So I clicked on it. Normally for long geometries, to get a normal view, you go to the front view and then you can rotate. Now this rotation is really quick because I have like an orthogonal projection. So if you hold the shift key, then you can do small rotation. Just as a remark, here we have a tooltip. So rotation mode, hold shift to slow down rotation. This is what we will do. I will zoom out, I will rotate a little bit more, and then we can see a 4-meter long pipe. I turn off the normal vector display, I turn on the volume view, and then we can actually see our pipe that we have built. Now, at the end of this pipe, we'd like to have a 10 centimeter diameter pipe. There are several ways to do it once again. I could either use the command that we know already, create shape, and I could say that this time the center position will be at Z equals 400. For that, I can select the end facet. I can click on the facet center button, and then he will tell us that he has taken the center of facet 39 as a center point. Also for the normal direction, I could do the same. So if I don't know which direction this facet is facing, I can simply take its normal vector, I click on it, and here you can see that actually the normal vector is pointing backwards to have a closed solid shape. So I can manually edit it to -1, or later I will just simply swap the normal. So to create a 10 centimeter diameter circle, I just give the new dimensions, I click on create shape, and I have created it. I want you to learn different methods of working with Molflow's geometry editor. So instead of this, I will use a different method. Basically, when we're changing a diameter, we're copying an existing facet and simply we're making its size larger. So for that, the facets can be actually scaled up. So I'm clicking on Scale Facets. The center will be the selected point, the center point of the selected facet. And I'd like to make this facet 2.5 times larger. Remember that originally this facet was 4 centimeters, and now I'd like to make it 10 centimeters. So I'm clicking, if I click Scale Facet, then you can see that he actually modifies the original facet. This is not what we want. So I will just undo this command by putting the reciprocal. So I'm putting this 1.2.5. So what I'd like to do instead is I will actually copy the facet, which means that he leaves the original alone, and then he creates a 10 centimeter wide circle. How can I actually verify if the diameter is 10 centimeters? I go to these details, which is showing me a list of the selected facets. I could even select both facets. And then I will be looking for the property which is called 2D box. 2D box is described by the UV vector. So you can see that every facet has like a local coordinate system, and that would enclose a bounding box which encloses the whole facet. And in our case, you can see that with a little bit of rounding errors due to the polygonization, we have a 4x4 bounding box and a 10x10 bounding box, so our dimensions are correct. Finally, I still need to make a 1 meter long pipe out of the 10 centimeter diameters. Here you can actually see where the normal vector is pointing, so I will just flip it to make sure it points towards the Z direction. And I will do an extrusion just the same way as I did before. So I click extrude towards the normal, and I like a 1 meter long path. So far it looks correct. We've got our two pipes. However, there is a problem. And for a vacuum simulation, you need molecules to be able to pass from one pipe to the other. Currently, the caps of the facets are solid, so they are preventing molecules to go from one to the other. So what would be the correct way to make a hole in the binding cap of the larger facet? You have two methods again. You select the two facets where you'd like to create the difference, and you have one command which is called transition between two. Now this is a generic command which you can apply between any kind of shapes. They don't even have to be in the same plane. If you click on it, then you can see that he has created these triangles which nicely cover up the hole between the two facets. So this is one way to do that. I will just delete what I have created. I select the original facets which are always kept for like safety. And I will use another command, is create two facets, and there you can use union, intersection, exclusive, or difference. And right now one facet is completely inside the other, so I can use the automatic mode, which will choose the combination which selects in a non-zero new facet. So I'm clicking on this command, and you can see that he has created a special facet where the outline is going in one direction, then he actually goes to the center line, he goes the other way around, and finally he closes the facet. So this is what we actually wanted. So now I can delete the original facets. 1 and 2, and I can double check that my volume is nicely closed. So at this point we still need to create the two pumping ports. Both of them are also 4 centimeter long pipes, 4 centimeter diameter pipes. One is 1 meter long and one is just tiny, so it can be, for example, 10 centimeters. Once again, here we've got the original system. It's not written here, but this is 1 meter long and this is like relatively short. So I'm going back to Molflow, and there are several ways to create a vertical pipe. Obviously, I could go still with the create shape command, and I would say that this time I want the center of the pipe to be at 1 meter. The direction should still go against the x-axis, but the normal vector should be against 1. So it is pointing upwards. However, here I have to do some coordinate calculations, and generally I'd like to do visual editing where you don't have to calculate coordinates. So I will just delete this, and we will see some different methods. One thing I could do is I could rotate this facet here. So I will go to the rotate command, and remember that the position of this circle is exactly at the 0, 0, 0 coordinate, which means that if I rotate around the x-axis by 90 degrees, then I can create a horizontal circle. So I will ask him to rotate around x and by 90 degrees, and I will not modify the original one, but actually create a copy. So here you can see that he has created it. Now at this point you could say that I had an easy task because the circle was at 0, 0, 0, and I would like a generic solution to make rotation possible. So I will delete this once again. And this is the time when we will be using vertices. So I go to the front view to see the system, and I would like to rotate around the horizontal axis this circle. So I will go to the vertex selection mode, and I will select 2 vertices. And these 2 vertices are on a horizontal line. So here, instead of the axis x, I will just ask him to rotate around an axis defined by 2 selected vertices. And this time it's a generic solution. I'm not using the fact that he's at 0, 0, 0. I'm copying the facet. I can click away. So if I'm looking from far away, you can see that I have created a circle. However, it's in the incorrect position. I'd like to push him by 100 centimeters. For that, I will use the move command, and the offset will be, either I can say that it's an offset to the z direction by 100, or I could even have the normal vector of the facet, or as an advanced mode, for example, if I'd like to move this facet from here to the beginning, from the beginning of the pipe to the end of the pipe, I can even do a distance measure. So I select this as the base. I select this as a direction, and you can see that the difference is actually 400 centimeters in the z direction. Anyway, I will actually use the absolute offset and simply push the circle 100 centimeters down the line. I pressed move, and now it's here. If you look at the plan of our system, then the next pipe will be 200 centimeters further down the line. So I will actually copy this facet. I could either put 200 here, or I can do a copy and then a move, and now I got 2 facets at the correct positions. So to make the pipes, I will actually do an extrusion. I can see that the normal vector is pointing upwards, so I will be swapping it. I will use the extrude command to do a small extrusion of about 10 centimeters, just enough to get out of the pipe. And here for the other pipe, I will use a larger 1 meter long extrusion. So here I made an error. Actually, by mistake, this normal vector was pointing upwards and I was extruding upwards. Either I could delete the facets and do the command again, or why not, for convenience, just use the mirror command. I'm mirroring to these facets at the top, so I will use the plane of it. And then I select once again everything, and I just do a mirroring, and here I have fixed my geometry. So right now you can see that something unusual has happened. We've got a pink facet here, and we've got a warning message that your geometry has null, non-simple, or non-planar facets causing leaks. If you actually do a debugging, then I will just go to the side view. And here we can see that there is a facet which looks absolutely like 0. So to see what's actually happening, I can go to the selection menu, and I can select these non-simple facets. He creates that. And then I click on the coordinates button, and then he tells me the coordinates of the 4 corners. So the reason that I have a very small facet with an area of almost 0 is that when I did the rotation, due to rounding errors, he created an extra vertex which is almost at the same place at the 20300, but there is a tiny bit of offset. So to fix this, I could either delete this facet, or there is a command which is called collapse. And with collapse, I will just use the first option, and I will ask him that if he finds two vertices which are really close to each other, 10 to the minus 5 centimeters, then merge them together. I click on collapse. He found a few vertices which are isolated. Isolated means that they don't belong to any facet. And with this, I have actually fixed my geometry. So now we're almost there and we're almost ready. However, we still have a problem. So you can see that in volume view that these facets are nicely intersecting each other. However, it's an end cap and still particles need to find a way to each other. So I'd like a nice T section, and it's possible to do that with the build intersection command. So I will go to facet, and there is this build intersection command, which is here. And then we can see the description of the command that you have to select all facets that form part of the intersection. So obviously these facets will be part of the intersection. I turn off the normals. And by pressing Shift, I also select these additional facets. I will actually unselect these just to make sure that there is no intersection created at this part of the geometry. Now it says then select vertices that you'd like to ensure are being kept. So this is a logic in Molflow to tell what to cut. Because Molflow is generic 3D, so it doesn't recognize what your geometry is about. We'd like this part of our pipe to be cut down, but this part to be kept. Remember that by holding the tab, so I could either switch to vertex mode, or I can also press the tab key and I can select the vertices that I'd like to keep. Now I have accidentally deselected the facets, so I will select them once again. I will add to the selection the two ends of the pipe. Don't worry if you have selected something else, they don't play a role because they are not part of selected facets. Now I can click the build intersection command. So if I deselect, you can see that he has done something which is not what I wanted to. So I will just undo it. Now the reason for this happening is that if I go to the top view and I start to zoom to the intersection, so you can see that instead of having perfect circles, we actually have polygons. And the edge of the polygons are intersecting the original lines. So at these points, Molflow has a hard time to decide which facet you'd like to keep. So currently this build intersection command has this limitation, and we will actually make this circle a tiny bit smaller, which will not change the simulation tools, the simulation properties, but it will make a nice intersection possible. So I'm going to the scale command. I'm going back to the normal view. I'd like the center of this facet to be kept as the invariant point. So basically this will be the center of the scaling. And then I'm selecting everything and I'm asking him to do a tiny bit of miniaturizing. So I'm keeping 99.9% of this. Now apparently nothing happened. However, if we zoom in, then we can see that this intersection problem that I described before is not there anymore. Now one of the circles is nicely within the other. So I will just repeat the command that I did before. I'm going to a view which is showing me the whole geometry. I'm selecting all facets and deselecting the caps. And I tell Molflow that I'd like to keep the ends. Now I click on build intersection, and this time he did exactly what he wanted to. He has nicely created the facets. And here there was no intersection. This was the end of the cap. This I don't need anymore. I will just delete, and now I've got a nice T section. I will repeat the process for the other pipe, and to show you that it's actually quick when you know what you're doing, I will just select this as an invariant point. I scale down the vertical section to 99%. One important thing to do is when you're actually selecting the facets that you'd like to make an intersection with. First I deselect these because this will not play a part in it, but also I don't want to remove these facets on the bottom line, so I will actually deselect every facet that was on the other side. And then when I want to mark what I want to keep, I want to make sure that it doesn't delete any of these endpoints here. When you get too many vertices, some of them isolated, it's a good practice to click on a vertex and clear isolated command, and then it keeps only those which are still part of the geometry. So basically, I like to keep these endpoints. I build the intersection, and he has nicely built the intersection, but by doing this he has also created a very tiny facet which is non-simple. We will just fix this, select non-simple facets, this is 0 area. Once again we will just do a collapse of nearby vertices, and that way we fix the geometry. So this is a good time to save our geometry. I will just call it like pipe. And at this point you can either stop because we have learned how to create a geometry, or you can watch the next video, which is showing how you can set up a basic gas simulation at this geometry. And if we did everything correctly, then we will get the pressure profile that we have in this paper or that we have at the benchmark tools.